Welcome to Summarize Science. Have you ever watched a drone race through a complex course and been amazed by its speed and precision? It's incredible, but there's often a hidden catch. The AI controlling that drone has typically only mastered that one single track. If you change the layout even slightly, its performance often plummets because it essentially memorized the course instead of truly learning how to navigate. But what if you could teach an AI to fly any track, even ones it has never seen before? That's exactly what researchers have done with a new framework called FalconGym 2.0. The foundation of their system is a hyper-realistic simulation built using a technology called Gaussian splatting, which creates a digital twin of a real space from a short video. But here is the revolutionary part. This simulated world is completely editable. As you can see here, their Edit API allows them to programmatically add, move, scale, and rotate objects like gates in milliseconds. This gives them the power to generate a virtually infinite number of unique training courses for the AI. However, having endless tracks isn't enough. You also need to train smart. This is where their second major innovation comes in, the Performance-Guided Refinement algorithm, or PGR. You can think of PGR as an expert AI coach for the drone's AI pilot. Instead of practicing on random tracks, the PGR system actively identifies the specific turns and gate layouts where the AI is struggling. It then automatically generates more of these difficult scenarios, forcing the AI to practice and overcome its weaknesses. This targeted training is far more effective than simply repeating easy maneuvers. So, what were the results of this clever training approach? In simulation, a single AI policy trained with PGR achieved a 100% success rate across 3 completely unseen tracks, including one with moving gates. This remarkable performance held true for 2 different types of drones with distinct flight dynamics, a fast fixed-wing UAV and a nimble quadrotor. The researchers also tested how robust the AI was by randomly shifting the gates' positions. As this graph shows, previous methods failed quickly with small changes, but the AI trained with PGR maintained a high success rate, proving it had learned to adapt rather than just memorize. But the ultimate test is bringing this into the real world. They took the AI trained entirely in the simulation and deployed it directly onto a physical quadrotor drone. With 0 additional real-world training, the drone navigated the courses, achieving a stunning 98.6% success rate over 70 gates. Let's quickly recap what makes this work so important. The researchers created an editable, photorealistic simulator to generate limitless, diverse training data instantly. They then developed a smart training algorithm that focuses the AI's learning on its specific weaknesses, just like a great coach. This combination produced a single, robust AI that can generalize its skills to fly new and unseen tracks, a major hurdle in robotics. Crucially, they demonstrated this isn't just a simulation trick, it transfers almost perfectly to a real-world drone. This technology could pave the way for more intelligent and adaptable drones for complex tasks like search and rescue, environmental monitoring, or autonomous package delivery. It represents a significant step toward creating robots that can learn in a safe, digital environment and then operate reliably in our messy, physical world. Thanks for watching Summarize Science.